What's going on, y'all? Today we are on lesson 14. The title of our lesson is What's Your Angle? In order to get to 14, remember, y'all got to go through lessons 1 through 13. So make sure you are all caught up. Most of us are. Awesome job. I'm very proud of you. Let's go ahead and read our objective for today. Our objective is students will be able to analyze, I was on lesson 13. Students will be able to define and construct triangles from given criteria. Explore symmetry in triangles. Okay, so we're going to continue to explore symmetry. I think a lot of you guys, if you felt really comfortable and successful in the last lesson, you're going to feel great with this lesson. It's sort of an extension of what we learned last week. All right. Once again, at this point, y'all should be done your Dreambox lessons for the morning. You should have your fluency lessons all done, your fluency components done here, so your number gym and your pair compare. I'm going to jump right into the learning lab, so let's do it. What's your angle? This is a pretty cool graphic here.
In this lab, we're going to look at all different types of triangles. We already discovered that we can sort triangles by their side lengths. We can classify triangles as equilateral, isosceles, or scaling.
My friends, I'm going to pause the video here. This is something that needs to absolutely be committed to memory. It's something that it has to be known. Okay, so you might want to write it down. You want to make sure you have the definitions down. If you're having trouble with this, reach out to me. We can work on it together. Okay, but just as a quick review, equilateral triangles have 3 sides that are the same length. 3 sides. Okay, isosceles triangles have 2 sides that are the same length, which means they also have 2 angles that are the same degree measurement. If there's 2 sides that are the same length, that means there's also 2 angles that are the same degree measurement. And scalene, they have 0 sides that are the same length. Okay? Each side is a different length. And so each angle has a different measurement. All right? Let's move on.
Did you know that there are more ways to classify triangles? We can also describe triangles by their angles. Let's learn about it.
All right. So before we go any further, we did talk about this on our exit ticket last week. And for my friends that had trouble with that, that's okay. I'm not going to count the problems that were just on angles. If you got them correct, it'll be a bonus. But if you had trouble with those, hopefully this lesson will clear that up, and I'm confident that it will. So we're going to start by sorting a few of these triangles. Our 2 categories: triangles that have right angles and triangles that do not have right angles. So I want you to drop these into the correct category, press enter, and see if you're correct. Okay, if you didn't pause the video, make sure you pause it now. I'm going to go through it and show you guys where these go. So if I look at this first one, I can see I don't have any right angles, no 90-degree angles. So this one does not have a right angle. This guy here does have a right angle. I can tell because it has this little right angle symbol in the bottom left-hand angle. And then last but not least, I have this cool little scalene triangle here. I'm going to drop that scalene right here because it does not have a right angle. Nice work. All right, our next job, let's sort these ones. Our categories changed a little bit. This time our category on the left are triangles that have an obtuse angle. What does obtuse mean? If you're thinking larger than 90 degrees or wider than 90 degrees or greater than 90 degrees, if we really want to use our math terms, you are correct. That is an obtuse angle. So then these are angles that are either 90 degrees or less than 90 degrees. Go ahead and classify them. Pause the video now, then you can check your work right afterwards. All right, let's check them. This first one here, okay, I can see my angle. I have acute, and a right. So this doesn't have obtuse. Here I can see acute, acute, acute. There are 3 angles that are less than 90 degrees, so there's no obtuse angles. And here I can see that this angle right here, clearly greater than 90 degrees. That's an obtuse triangle. Let's pop it right in. Nice job. Okay, we're going to sort it one more time. Our category on the left, triangles that only have acute angles. On the right, triangles that have angles that are not acute. Okay, pause the video, answer this, and then you can replay and check your work. Okay, I can see all 3 angles here are acute. They're all less than 90 degrees. I have 1 angle here that's 90, so that'll go into our right category. And then I have our obtuse angle here, so that'll drop right down into our right hand category. Nice job.
Great work. These triangles have special names. If a triangle has 1 right angle, it's called a right triangle. If a triangle has 1 obtuse angle, it's called an obtuse triangle. Acute triangles are a little different. To be called an acute triangle, all of the angles must be acute. Acute triangles have 3 acute angles.
All right, my friends, lock that into your memory. So we have some new ways to categorize triangles. Again, I talked about this in the last video. It's something that we want to commit to memory. If you have a triangle with 1 right angle, 190-degree angle, it's called a right triangle. If it has 1 obtuse angle or larger than 90 degrees, you call it obtuse, an obtuse triangle. And if it has 3 acute angles, it's considered an acute triangle. Now, as we're going to learn, triangles, usually you can classify them in 2 categories, by side length and by angle measurement. So I might have a right triangle that is also an isosceles triangle, just like this. Isosceles. Okay? Because these 2 side lengths are the same measurement. It's got that right angle, so it's a right isosceles triangle. We're giving our triangles 2 names now. So we really have to be like, think of ourselves as we're geometric detectives, okay? You're always looking for clues to see how you can classify and categorize these shapes. Let's keep it moving. All right, let's classify this triangle. First, classify the triangle by its side lengths. All right, let's take a peek at this. You might want to pause the video and try it yourself before I do. Okay, so if I look at my sides, it looks like they're all different. Shortest, longer, and then our diagonal here is the longest. So if they're all different side lengths, we're going to consider that a scalene triangle. Okay, and it looks like, it's not marked here, but this does look like 2 perpendicular line segments to create a right triangle or a right angle. So that's going to be a right triangle. Pop that in. Does this triangle have any lines of symmetry? Well, we know it's right and scalene. Okay? And for lines of symmetry, our side lengths tell us whether or not we have lines of symmetry. And if we don't have any side lengths that match, that are the same length, then that means we do not have any lines of symmetry. Scalene triangles do not have lines of symmetry. Nice work. Okay, I want you to try this on your own. This triangle is what? Okay, if you said equilateral, you are correct. 3 equal sides, 3 equal side lengths. All right, now we classified it based on side lengths. Now let's classify based on angle measurements. Is it acute, obtuse, or right? Well, acute would mean that all 3 angles are less than 90 degrees. And it looks like they are. They're all folded a little bit less than what a right angle would look like here. Nice job. Does this triangle have any lines of symmetry? Remember, it's equilateral. I'll just write EQU, okay? So when it's equilateral, 3 sides are the same. That means it has 3 lines of symmetry. There's one. I could fold it on top of itself perfectly. Here, I'll do them in different colors. Let's do this one green. And the last one we'll do red. 3 lines of symmetry. So yes, it does have lines of symmetry. All right, I just gave them away. All right, I gave you a nice little hint. See if you can do them on your own. You might want to pause the video now and then check your work afterwards. All right, my friends. So what you want to do is make sure you line those up. You're going to have to select your points that you want to match together to create that line of symmetry. I'm going to draw 3 of them, and there they are. Nice job. Okay, this one's a really funky one for a couple reasons. Not only does it look, it's a little awkwardly shaped here, but it's also sort of oriented or turned on its side. Okay, so the base isn't on the bottom. The base is facing to the left. So this triangle is a what? Pause the video, answer, and then check your work. If you said isosceles, you are correct. What makes this an isosceles triangle? Well, isosceles triangles have 2 equal sides. I can see my tick marks here tell me that this side and this side are both the same length. Nice work. All right. Is this an obtuse, a right, or an acute angle? We already know that it is an isosceles triangle, but how can we classify it based on angle? Well, it looks like it has at least one obtuse angle, and if a triangle has just one obtuse angle, it's called an obtuse triangle. Now, I want you to tell me in a Google, you can answer me in Google Classroom, all right? So send me a private message. This is a challenge question. Can a triangle have more than one obtuse angle? Why or why not? Can it have more? And you need to explain yourself. Why or why not? Pause the video now. I'll see you in a second. Okay. So I saw some really cool answers. A triangle cannot have more than one obtuse angle because an obtuse angle means that it's greater than 90 degrees. All right. It's bigger than 90 degrees. So if I have 2 angles that are larger than 90 degrees, let's call them just 91. Let's go 1 degree larger. So one angle is 91 and another angle is 91. 2, 1. That's 182 degrees. That's more than I can have in a triangle. Triangles are worth 180 degrees total. 180 degrees total. Okay? So, and that's it. When I add all 3 angles up, that's 180 degrees. Okay? Keep that in mind. You're going to need that when you go to your exit ticket. So no, triangles can't have more than one. They can only have one obtuse angle if they're obtuse. Let's keep moving. Does this triangle have any lines of symmetry? Go ahead and answer. If you said yes, you are correct. This is an isosceles triangle. Isosceles triangles have 1 line of symmetry, just 1, okay? It splits it right down the middle. We went ahead and drew it. Nice job. Okay, what do all of these triangles have in common? This one's a little bit tricky. I want you to answer the question and then check your work. You can pause the video now. Okay, if you saw that they all had 2 tick marks representing 2 equal sides, you were correct. That means they are all isosceles. Very good. What do all of these triangles have in common? Go ahead and pause the video, answer, and then check your work. Okay, if you said that each of these is a right triangle, you're correct. Check it out. I see right angles, at least 1. Very good. They're all right. And just like our obtuse triangles, triangles can't have more than one right angle either. And the reason is because if I have two right angles, that would mean there would be no degrees, there would be no measurement left for a third angle. So it wouldn't work. Okay. All right. That's illegal. All right. That's like a cardinal law. That's a rule of nature. All right. You can only have one right angle if it's a right triangle. Oh, challenge time. We love a good challenge here. Let's do it. All right, I want you to pause the video and try this challenge on your own. You're going to be labeling these, so pay very close attention. You're going to want to drag and drop and then press enter to check your work. Pause the video now. Come back and check when you're done. Okay, you're back. Let's take a look at our categories here. When I look at this first category, I look at all my angles. Let's deduce what I'm looking for. Okay, I see a similarity here. I see every angle is less than 90 degrees. That means every angle is acute. Say it with me, acute. Boom. These are all acute triangles. Let's look at our next category. Let's pay close attention. I see some obtuse, but this one doesn't have it. Okay, oh, I see something. This triangle has two tick marks. That means two sides are equal. It's isosceles. Same with this. Isosceles, and same with this. Three isosceles triangles. Now this one here doesn't have any obtuse angles, so they can be classified differently based on angle, but based on side length, they're all isosceles. And last but not least, let's analyze these. Let me put this detective cap on nice and tight. This one's easy. I caught it quickly. 1, 2, 3 right angles. They're all right triangles. 3 for 3. Home run. Nice. All right, my friends, let's move forward. Oh, we earned a great job. Okay, I feel confident that you guys can handle this on your own. So I'm going to go right to my exit, or to our exit ticket, Edge Elastic. That means I'm going to pause the video for a second. You should too. Finish up your tower of power. Once you're done this lesson, head on over to Edge Elastic. I'll give you some tips, tricks, hints, and some just general support to help you through that. All right, nice work. I'll see you all in a second. All right, y'all. So we are over at our exit ticket. We're in Edge Elastic today. You guys will be doing it Monday, May 4th. Some of you may be doing it at a later date. That's okay. But this is what the exit ticket should say. Again, make sure you're watching my YouTube video and completing Zearn lesson 14 before you do this. All right. Some of these answers are going to be written out answers, okay? So make sure you're explaining your solution in at least 2 sentences. Question 1, if triangle ABC is equilateral, line segment BC, must be 2 centimeters. Is this true or false? If it's equilateral, is this true or is this false? What do you think and why if this is equilateral? Think about what equilateral means and think about if that would be true or false. Question 2. Same setup here. You're going to have to explain your answer in 2 sentences. EFG can be described as a right triangle and an isosceles triangle. Can we have a right triangle and an isosceles triangle? Tell me if it's true. Tell me why. Tell me false if you think that we can't have a right triangle with an isosceles. I'm going to let you guys do this on your own. If you have to go back and watch some of my video, feel free to do so. Let's go to question 3. Triangle ABC has one line of symmetry, as shown. Here's our line of symmetry. Is the measure of angle A, here's angle A, I'll do it in green, greater, less, or equal to C? Is A the same as C, smaller than C, or greater than C? How do you know? One line of symmetry. I want you to think about what type of triangle only has one line of symmetry. Okay? Think about that classification and what that means about its angle measurements. Make sure you're explaining in at least 2 sentences. And I get throughout this video, there were tips and tricks, but if you're having trouble, again, reach out to me and I'll give you guys some advice, either over the phone or on Google Classroom. For question 4, triangle DEF is scalene. Start to think about scalene. What does that mean about your side lengths? What do you observe about its angles? So think about the side lengths and what does that mean about each angle, okay? I would think about in terms of the angle degrees, all right? Are they the same? Are some the same? Are they all different or just some different? Start to think about what that word scalene means. All right, question 5. If the perimeter of an equilateral triangle is 15 centimeters, what is the length of each side? Okay. So you need to think about what an equilateral triangle means and the perimeter. So the perimeter of a shape is the outside. That's a weird looking shape. We'll use a scalene triangle here. So the perimeter would be this, the distance around the shape, the border. So if the perimeter is 15 centimeters, okay, and it's equilateral, so not this one, you're going to use an equilateral triangle, okay? What is the length of each side? For this one, all you need to do is put the length of each side right into this box. And then last but not least, can a triangle have more than one obtuse angle? I was very clear with this answer earlier in the problem. For my friends that went to Google Classroom and answered it, you've already thought about this one. Make sure you write your answer in at least 2 sentences. Tell me why or why not a triangle can have more than one obtuse angle, or if it can't have more than one obtuse angle. All right, y'all. Great work. You've done a fantastic job with triangles. I'm very impressed. On Friday, if you are viewing this on, well, you know what? I'll send you a message in Google Classroom, okay? So I just want you to have a great day. Good luck on your work. If you need help, reach out, and I will talk to you soon. Peace.